welcome to another podcast with DigitalWERX TV. And with me today is our guest, Saulius Pavalkis. And you work with Dassault Systems?
Yeah, Dassault Systems.
Okay, and your title?
Mbse Ecosystem Director.
All right, and I know that that title does not completely cover everything that you do.
Yeah, we do like solutions, and its complete title would be Senior Director for the Mbse Solutions.
Mm-hmm.
And the scope is pretty much the most senior team in North America for system engineering and all the integrations related to system engineering.
Okay. So you just finished the last 4 hours of another workshop, and I know that you've done those workshops all over the country, probably all over the world, getting the message out. You know, what is it that you've been talking about for today?
So today was talking about full engineering life cycle, that we can actually have a very fast return of investment if we have engineering data connected through the models, model-based. We can do the change and see the impact immediately, and we can do it even faster if we run cost simulation of the data. But looking pragmatically, just have a baseline managed and have traceability, and then use it for change impact and configuration management.
So a little bit more of an applied application or an applied use of what we've been doing with Mbse.
Yes, exactly. And those research on return on investment, they're happening for years, And I think what was like not clear when you say like, okay, will Mbse help you to do the system engineering faster or better? If you do it first time, it takes time to build a model, takes time to learn. But when you have it, then it is unbelievably faster and less problematic to do the change and configurations using that investment already. And this is actually unbeatable, the return of investment. It's not even compares to work done in Excel or work done in disconnected solutions, which are, in most cases, they are not model-based, because model-based you can connect the semantic data, right? When it's not model-based, when it's like completely isolated environments, then you kind of redo everything, and you need experts for any change.
Mm-hmm. Well, that's one of the things that I've been talking about is if you're not using a model-based systems approach, you're really introducing a lot of human error to go from one spreadsheet to the next or one document to the next, where you have this single source of truth.
Absolutely. I couldn't agree more.
Okay. So I just skipped through one of the things I wanted to ask you is, how'd you get involved in all of this? You've got a long history in this digital engineering world.
So after my internship in the Finland, after the bachelor's, I had internship in a great company, Vaisala, which does meteorological equipment, weather stations.
Mm-hmm.
And one of the leaders, I had opportunity to, because I finished my, internship like in middle of the year, so no studies was at that moment, available. So I had opportunity to look for a job, and by accident I joined No Magic. They were looking for quality assurance engineers. So that's how my career started in a completely new area, which gave enough challenges to become almost like from second year analyst of the core team, and then product owner, and then switched to the solutions, and then did before that even PhD in the same area. We had amazing professor of UML related, rules related modeling in Kaunas University of Technology. So I did PhD there together with my colleague Aurelius. Many people know he's co-chairing QAF standards. So we did PhD together on different topics completely. My topic was traceability. So as you see, it's still there. Traceability, actually, the query language was created as part of the PhD, which evolved a little bit, no, not a little bit right now, but still was like meta chain introduced. Again, based on my colleagues, feedback and thought process, it's never isolated, as you don't want to do everything from scratch. So became powerful query tool in the Cameo, now CATIA Magic. And now I'm here, after many years of training and consulting in the US, and now do the solutions, consulting internally for other teams like service team and local consulting team, but also for the clients. And we are a global team.
Mm-hmm. So you live in Texas now?
I live in Texas, in Dallas, north of Dallas. Oh. There was like headquarters of No Magic.
Okay.
That's how I came there.
Oh, I was wondering because Finland and Dallas, Texas, a lot of difference.
Yeah, a lot of difference. And I was living in Lithuania for all my life, except few cases. And then I moved to Texas, but it was such an easy move because of the company doing all the work to enable that. It's almost the only way to transfer, to US. And the reason was that in the US, there was a lot of Mbse and system engineering specifically. At that time, 10, 12 years ago, it was not so much in Europe, which is getting better, but compared to North America, it's like deep knowledge is here.
Well, it seems to me that Germany might be leading us just a little bit from the adoption of model-based system engineering. Is that roughly?
Automotive industry in Germany and in France, and also Airbus and related companies. So those are the primary pushers in Europe.
Okay.
Yeah.
So Mbse, at least in America, has been moving, but it seems to be going in spurts. Do you see a strong adoption of moving to this model-based system engineering, model-based engineering approach across the nation?
I see that progress is made every year. I see that growth, and we can check also data on support tickets. We can check data on license sales and other things, and number of interactions with the clients, number of internal teams. When I came, it was like just small team in US, and now we have like multiple teams doing similar things and partners network and other things related to that. So definitely, and it relates also to the qualification, and if you do the trainings, if people are adopting, then you get like some outcome of that.
Okay.
So it's like related to qualification and also the quality of systems. Because if you want to build complex systems, you need some transparency, and Mbse maybe is the best way to get that transparency.
Right. So we're seeing it in the aerospace and defense and automotive industry, but there's a lot more you can do with these tools than just in that regime, right? Have you been working in exploring that into more of the business community, like you were talking about today, and how you can do things quickly?
So yeah, that's what you see here. Even today, it was like a presentation based on the robotic arm, right? Not related to defense or automotive deliberately, because it was like just small system. What we see is that for teaching, it's easier to have easy to understand system instead of have subject matter expert related to decisions which are requires a lot of insights. So that's what I think successful. This sample we started to use and distribute. We already got like tens of requests, maybe 20 or 40 requests already this year. We plan to do another 5-10 workshops this year, and then get like maybe 100 people adopted this data set. I think partially because it's a like simple system and easy to understand and transfer to other domains, but also defense and also automotive. But there are like robotics manufactured, surgical robots and so on, which benefits from Mbse too. And we see that growth also in those areas, high technology areas.
I think that's where I first ran across you, was a YouTube video on the robot, the Lego robot. And it was very interesting that you used that as a demonstrator because, and correct me if I'm wrong, but I have stated that using these SysML tools, it's like a non-executable program that has a lot of elements, but you're showing it to be executable. How does that work with the tool?
So first of all, maybe why executable, right? Because a big part of SysML is not only a static check of the system and the model. It's also behavior side, right? Like SML is heavy on behavior side. And to check the behavior logic, you need to really execute. You can't do it another way.
Right.
Plus, you can learn the model faster when you execute and see how it works. And there are a lot of mistakes in diagrams if you don't execute. You can check on Google activity diagram, and you will find those non-executable. And then why the system? Because then you can check yourself, is it really working? Because there's another thing that you can build system model, but is it correct? So somehow you need to have that feedback loop. One thing that it simulates, another thing it simulates with some other thing in the loop, like hardware in the loop. Then you are like very pragmatically correct or not correct. You can check yourself, And this gives such insight, in real systems, because all the timings and, controls of the hardware and limitations, power usage and other things, opening interface, closing interface. I think this is like simulation is one level, and then simulation together with virtual environment or, hardware is another level. It was always fun to have also full control of the hardware, which is like, let's take that Lego robot, right? Lego has control environment, right? You can code in that environment, but really, if you know SysML, it's easier to use the library, drag, connect, and simulate in that way than using their own proprietary environment. So kind of gives insight that actually maybe this modeling piece is not bad, actually, what we are using. Is not only, just because it's SysML, maybe because it's actually easier to use than anything else,
Well, that's an interesting thing to be able to tell, I think, the community that's adopting Mbse, because one of the first obstacles that I have to overcome is that Mbse is too hard for me. But really, it's a very powerful tool if you just spend the time to use it.
Yeah, that initial adoption you require to spend time learning, but it's almost like you build first Magic Grid-based tutorial, Magic Grid-based, model, and then you already know how to build another one, and then it depends what direction you want to go.
Right. So I know that we had professionals in here today, and that's what you were demonstrating the robot there, but that seems to be so powerful for the young generation, middle school and high school. Is that something that any of us could put together and simulate through the tool?
Yeah, that's the goal, of this sample set. We have like 10 models and hardware, which hardware is very affordable, like $60 to buy and assemble by yourself in 1 hour. And then we give those models for free. You just take the tools, which you can have academic version of the tools, and you have commercial version, and then adopt. And the primary goal was actually maybe digital engineering curriculum for the universities, because it takes time to understand how that could work, and how to use the tools together, and ways that data to get in from, like you can get like some one or another sample, but it's not so much connected and dedicated for that purpose, and once you adopt, I think this data set, which to deploy takes like 4 hours from zero to like completely deployed on a new environment.
Okay.
Like every model will be added and running together. Then you could see and use and demonstrate and have another project built in similar way. That's, I think, the fastest way to adopt, model-based digital engineering.
I agree. I think it's a great demonstration.
Thank you.
It's really, really handy, because so much is visual of what you're doing, because when you first look at Mbse, it might not be so inherently understandable. It's a very powerful program, but it's logic-based. So you're looking at what can be, right?
Yes.
Yeah.
Yes, what can be, what every tool is doing in a specific discipline, what's the power of that discipline, and then, how that especially connects to a rest. You can have them work together.
Right. So here in Huntsville, Alabama, one of the things that we've been trying to do is to get the word out. What can we achieve with model-based system engineering? how do you think is the best way to get a new community adapted to using model-based system engineering and the tools that are available?
Sure, to show the value, maybe, like it's, actually, I think the university should teach that, First of all, they should do not theoretical, but actually more practical.
Right.
And, someone would say, okay, it's tool agnostic, but then don't go tool agnostic, show how that actually is used, in the tool, but not like to promote the tool. And that gives like ability to understand and see the value and to immediately get like right qualification to use it. Many things can happen at once. And, this is all about, I think, ability to go right direction, because someone can get certificate of, system engineering, model-based system engineering, and still use PowerPoint. And I don't really see the value of that, They just put the checkbox and that's it, But if you actually apply this data set, which I don't want to promote, but just like, this is like such an easy entry point,
Right.
And then you can just leverage that, and then get like practical knowledge for someone who is looking for next work opportunity or just improve their.
Well, that's one of the things that we decided at California Community College. If we're going to teach how to be modelers, we had to select a tool and teach the students how to use the tool. And that's what we've done with Cameo and put that together. And it's really turned out some good modelers. If that's not the tool they use when they get to industry, they can transfer that understanding of how the language works and how the tool works and apply it to something else.
Absolutely. It's very similar to other tools. Maybe usability, maybe other things is different, but still you get like still language the same, right?
Right. And I may have said the tool wrong because I followed the change of the name from No Magic and to where it is now. So what do we call the tool that Dassault is selling now?
Its new portfolio name is CATIA Magica.
Okay.
Its capabilities are now bundled more tightly because it was like hundreds of plugins or more than 100 plugins which you could install, and now you get everything like in one of 4 bundles. Actually, for three bundles. It's still UML for software, then SSML for systems, and UAF for enterprise and mission engineering. Those bundles. Roughly talking, it's not like such a strict discrimination, but and then you get almost like all the like required plugins together, and it's easier to install, and the new naming relates to new, portfolio and other things.
Okay, so it's the CATIA Magic.
CATIA Magic
is what we should call it now.
Our portfolio name is CATIA Magic.
CATIA Magic.
Yes.
Okay, so is it wrong for me to say Cameo anymore?
Still available portfolio for existing clients mostly, or the clients working on that project which uses those products, but they are kind of compatible. You can even have like both working together. It's yeah.
Okay, well, very good. So we know where we've been and how we're getting there. What do you see the future of digital engineering and how this fits in?
Yes. So I think it's like very important to talk about automation with AI, and if we are lucky, it will help us to do those hard tasks in the future. Which I don't know what are those tasks, specifically for every company, maybe a bit different, but there will be like more like easier ways to achieve the goals. Like, for example, change impact analysis, like it would be maybe smarter with AI. It knows your data. It can say, okay, consider those things, maybe, converting from textual specifications to model specifications, suggesting the model elements. But those things like will happen, there are some disadvantages of that because like currently, if you see the model, that someone invested time building it. Plus, you see the quality of the model, so you know that it's actually the architecture was created with some, considerations. But if now in the future you will see the model, you don't know is this AI build the model or not. Then it will be important for us to take a look actually to the architecture, which is not the model. And it's even confusion right now. People say, let's build SysML model and let's do Mbse. It's from system engineering side is like, let's optimize on system architecture that it would be the best. And if you build any systems, you know that it's actually hundreds of thousands of methods to have that implemented, or architected and designed, right? So you can choose, and which one is better in the specific situation depends on user needs. And actually, if you are doing kind of correct or any kind of like optimization on the best architecture, you can get that done easier with SysML or system engineering for sure, and then show that architecture, show that process, that you captured correctly user needs and that they were addressed in system requirements, that the system requirements led to optimal solution architecture. And that will be important, I think, once AI will start generating those models left and right,
Right.
We should take a look at that, And then the future maybe of the system, of the Mbse would be like, for example, we never had, code generation from legacy systems, not code generation, but reverse code from legacy systems, understanding the code and building the logical model. Could be like thousands and millions of, lines, millions of lines, and AI could do it, right? And could build a SysML v2, why not? Now we will be able to take a look and control that. And especially if, people start building apps, with AI. Okay, so who knows what cybersecurity safety is there? So we need a model to understand that it's using those libraries, that it has some requirements related to those interfaces. Even to change the code, you would want likely from model, not just by typing prompt, which updates suddenly like everything, which does not control anything, from your perspective. So it's kind of like more automated, but at the same time, user will be more powerful using those environments for system engineering.
Yeah, it can be more powerful, but we still have to have some checks on our verifications and just verifying and checking, and did the model, was it created correctly?
Correct.
And AI is going to get better.
Yes.
But for a while, it's going to be a little bit of a ramp. We should revisit this, and as we know that AI is a big topic right now with our young people, we are going to see a lot of changes and advantages and advances in AI implementing these tools.
Yeah, automating. I would say slow automating,
Right.
Yes.
Right.
It still does not remove, someone deciding, is this the best architecture, I think this is like the last scenario which will be automated, because you need to kind of take a look and decide, is this, really what we want? And
yeah. Let's be sure that the tool is helping us and we're not helping the tool. It's a way for us to think through the system.
Yes.
Well, Saulius, I really appreciate you taking the time and spending some time here on DigitalWERX TV with us and with our podcast. And I'm sorry that we don't have our normal studio host here. Steve Johnson's on vacation. You've got Chris Crumbly here for DigitalWERX TV. And that's going to close out this section. And just remember, as Steve always says, it works.